Right, let's see if we can build some high scores for this thing to go on the right here. Okay. Step 1, we need somewhere to store the high scores. So there's a score. Let's make a thing called high scores. We should probably put some info in here just to have something to show. Name equal to test 2, test 3, and then like that, just so that there's something in there. Okay. Then when we draw UI, we draw the score, and then we're going to draw high scores. Okay, so then I need to make this function. So we'll put it right here. Spacing is funny there. So the print command takes an x and y, and we need to print in a different line for each line of the score. So we probably need a line number. Okay, this is in pixels. This will be our y address, so the y position for each line, and then we'll increment it. Okay, for I actually go from 1 to the length of high scores, although we'll probably decide how many high scores we'll have in the list, 5 or 10. I was thinking 5, but the way I'm thinking of designing it, we will actually have space for 10. But we can decide when we get there. So for each one of the high scores, what we do is just going to make a quick reference to it, just so it's easier to address. High scores I equals. Okay, then let's just print the name first. Maybe the number in the front, followed by a space, followed by score.name. Okay. Now when we're printing our score, that's a good indicator of our left edge. Now our y-axis will be at score line. Color is white. Fixed width is going to be true, because then the numbers will line up nicely when we get to the numbers. Scale 1 and then tiny font. Okay. Oh, everything's printing on, it's printing all the high scores, but all on top of each other. So what I forgot to do was, when I'm done printing a particular score, I need to go score line is equal to 1 plus, how much do we put between these? 8. Yeah. So 1, 2, 3, and then the score. Now we need to put the scores next to it. Print sc.score at, how did we calculate? When we did the UI rectangle, we did 240 minus border minus UI break. Oh right, that gives us a width. We don't need a width, we need a position. So we can go 240 minus border. That's the right edge. Minus arbitrary number. That's the x-axis. Y-axis would be the same. and then everything else will probably be the same. Oops. Attempt to index a null value underscore SC. Somewhere I put SC, but not the underscore. There we go. Yay! So names on the left, scores on the right. Now the scores are all the same number of digits at this stage, but if, for instance, one of the scores had a fourth digit, see, now it lines up on the left, and it's difficult to see which one is the bigger one. So let's quickly make a function that aligns to the right. Debug trace grid. You know, we've just got a bunch of helper functions at the bottom here. It doesn't really matter. Function. Let's call it print right. Hey, didn't we have? Where's our print shadow? Print shadow. Let's put it near here. Okay. Take text, X, Y, color, fixed width, scale, small font. I think that's everything we need. Okay, what do we do? So print has this handy thing that if I print text, this is the text. I don't know if I've mentioned this before. If I print like this and I set its return value to a variable, that variable is the size, the length of this text in pixels. So I can use that. I can, for instance, print my text that I'm passing in, print it at its x coordinates, but then at like -1000, so it's completely off screen. And the rest of the stuff we just pass as normal because we needed to render as close to the actual size as we want, so that we get an accurate size for how big it's going to be. Okay, so now it's going to print the text like it's supposed to, but somewhere where you can't see it, and return us the width of that text. Then we print it again. Actually, we can just take this. Now we print it again. This time at the Y position we want to print it, but because we want to align it to the right, we minus from it the width, which means the Y, no, not Y, X, at the proper Y coordinates, but the X coordinates we offset by width, DTH, width. In other words, when we call print right, the X coordinates we're sending is actually the right edge, not the left edge. And then everything else remains exactly the same, meaning we printed exactly the same size and everything as we did above, just where it's supposed to be, in the color it's supposed to be, and everything. So, grab this, go back to where I draw high scores. And then here, instead of print, print right. And then make it, because from UI break we go 4 to the right, so from the border we go 4 to the left. And now those are all neatly right aligned, and our spacing makes sense. Does it? That feels a little further away than this does. It's close enough. This still lines up to that, which is all that I care about. Hey, we can actually do the same with our score at the top. Where do we? There, score. Let's do the same thing here. Let's print the word score there. And then print the actual score at 240 minus border minus 4. Height is border plus 4. Color is 12. And the rest we don't have to pass. And this needs to be print right. Now it's not printing its score. Do I need to pass the rest of the values? I didn't think I needed to. Okay, let's just make sure that our score prints properly first. Let's just do a normal print. Yeah, there it is. But then the only difference is that I'm now calling print right. And I am, yeah, print right. Okay, maybe I do need to send it everything. So scale, where this goes, text X, Y, color, fixed size, scale, small font. There we go. Oh, while I was testing out my code beforehand, I noticed, look, my score is 2. My score is still 2. We're not resetting our score. But that's a quick fix. We can do that now quickly. All we do is we go to boot, and once we have reset our fruit and the snake and everything, before we do our first move, we just go score equals 0. That should reset our score. Okay. I'm terrible. Okay, now we need to actually make the thing ask us for our name when we make the high score. So firstly, let's add one more high score entry in here. Call it name is equal to, doesn't really matter, but we're sticking to the idea of capital letters. And the score is going to be 1, so that I have something to beat. Okay, then when we draw game over, okay, this draws the game and then the word game over, and then it waits for a key press. Okay, let's make a new function called draw UI game, called draw game over UI. Draw game over UI. Sure. We're still going to draw the same rectangle. Then, I think in normal situation we should print the same score thing at the top, like so. If score is greater than the lowest, are we going to assume that high scores will always be in order? So the one at the bottom will always be the lowest one? Probably. Dot score. Then else we print this as normal. But then we print high score. Maybe still with the score next to it. I don't know if that spacing is going to work out if the scores get super long, but we can worry about that later. And then here we need to now draw input. I don't like using the word input because it sounds like a command, like if you're waiting for key presses. It's fine. Else we just print the score as normal. And then probably just the, what did we call it? Draw high scores. Yeah. This feels like a lot of code duplication because I've essentially written this entire thing over just with one extra if. So wait, you know what I can actually do is I can just call draw it's draw game over UI. There's the rectangle, there's this if. For the else I can just call draw UI. There we go. Okay, but I still need to code draw name input. Draw high scores. Function draw name input, I called it. Okay. This is going to need some stuff. Because how this is normally done is you have like the, say it's 3 letters like AAA, right? Will pop up for you to put in your name, and then there'll be like a thing and then the score, right? And then the particular letter that you're on would be blinking like this, and then you can press up and down to change the letter to what letter you want, and then press right to go to the next one or left to go back, and then when you press enter then it commits. I'm thinking of like the Pac-Man high score, which is kind of what we're doing, right? That is basically what we're coding. So we're going to need a list of characters to use. Let's just put our bookmark here so we know where we are. So there's a handy thing, help keys. Okay, so if you look at the numbers that are associated with each letter of the alphabet, it goes 1, 2, 3, 4, 5, 6, 7 up to 26. Then the numbers start from 0 at 27. That goes up to 36, and then there's some basic punctuation, minus, equals, left bracket, right bracket, backslash, which I think I need to escape if I'm putting that in a text string, semicolon, apostrophe, grave, comma, period, slash, and then space is 48. That pretty much gives us everything that we need in a nice organized sequence. So at the top of our file here by our globals, we're going to add, here's one I prepared earlier, this letters as a global, and it's essentially that exact sequence, 1 through 26. Then from 27 to 36 is the numbers 0 through 9, well, 37, I don't know. Then minus, equals, left bracket, right bracket, backslash, which is typed twice because it needs to escape, semicolon, apostrophe, grave, comma, full stop, forward slash, and then the space. Okay. This allows us to do some funky things. We can now, anywhere in code, I'm just going to stick it at the bottom here with our other helpers, we can write a function called getLetter, pass it a letter, which can return a particular letter from that array based on its index. So you can't just, I can't just go like this. Like that will not give me the second character in the string. Python does that, I believe. C# can do it. Lua cannot. If I do this, it tells me that I'm trying to read a string, not a table. But what I can do is I can substring, subdivide the string, which is what this does. So return letters sub from position L to position L. Those are L's. So in other words, if I now call getLet and I give it the number 2, it'll give me B. And if you remember from our little thing, 2 is B. And you can do the reverse as well. This is a bit of a crappy name for for a function, but I'm going off the idea of getters and setters. SetLet can do the opposite, where I can give it a letter and it can in that list find the letter and give me back its index. That does work in Lua. It's with in both these cases it uses the colon syntactic sugar, which means that it's calling sub on letters, passing letters as the first parameter in the thing. Same with find. It's like calling string.find letters and then the L. So this allows me to convert from a number to its corresponding letter and back using that constant, that long constant we have at the top with all the letters in a row. And it means that when we print letters to the screen, we can cycle through them with up and down arrows. So, let me think. We need to store them in number format for the display. So let's just call that entered name. And this is going to be an array with, I think the standard answer is AAA. It's normally what it pops up as. The fact that it's 3 length is arbitrary. The way I'm thinking of saving this in persistent memory, we can actually have a name of 9 long. But it also depends how much space we have on the screen. So your results may vary, I guess. Okay, and then we also need the current letter that we're focusing on. Make it the first one. Okay, draw name input. So for I, V, you know this sequence already. In pairs for, what did I call it? UI entered name. Do. So for each letter, I need to print that letter to screen, but it's saved as a number up top, so I have to get let that value at UI break plus 4 score line is going to change. And I need to print this in the same spot as the score line up there. Hold your horses. That 40. I guess I can just hard code it. 40. Color 12. False. 1. True, because we want it to be in the small letters. Okay, but this is all going to print on top of each other because this all has exactly the same x values. So instead of plus 4, we're going to do a 4 times I, which is going to take UI break and add to it 4 times what my integer is. So the first letter in the name is going to be at UI break plus 4. Next one's going to be at UI break plus 8. Then 12, then 16, and so on. Now I actually need to score more than 1 point to end up on the leaderboard, otherwise it's not going to show. Oh wait, I'm not actually calling it yet. Boop. I'm not actually calling anything yet. Where is it? Draw game over UI. Is it in TIC? Game state 2. Countdown. No, game state 1. Game over. Draw game over. Draw game over UI. Like such. But then this draw UI needs to go in place to all the places where it should draw. That's not this one. Okay, that was pretty easy. 2, 1. Quickly get a point. Get another point. And now if I die, boop, it broke. Attempt to index a null value high score. That's at line 255. Go to 255. Did I forget the S? If score is greater than high scores dot score, then print high score. Okay, let's try again. Oh, not enough. Yay, high score, and then the word ah. Okay. At least we know it works.